So I hope that you remember complex numbers, but if you don't, this will be the fastest lesson on it ever. I cannot spend the same amount of time. You're going to think, this is insane, he's going so fast. Remember, I got to cover a month worth of material each day this week, this short week, to be able to have you ready for the final and have talked about everything. So it's going to go really fast. All right, so this first one, I know the answer is 2i, but do you know why? Well, because it's really two square roots, square root of 4 and the square root of negative 1. I make sure you get yourself called in then.
Yeah.
All right, so this is going to be 2i. Well, 2i is because the square root of 4 is 2, and because the square root of negative 1 is I. So that is called a complex number. A complex number has a real part and an imaginary part. It's just that the real part in this case is 0. Could I have said 0 plus 2i? Sure, I could have. But you don't have to. But that is the real part. It just happens to be 0. So these complex numbers actually have a real component and an imaginary component. And this one's real component just happens to be 0. All right, that's a lot, isn't it? This one, you'd be thinking 3 times the square root of 169, which, anybody know that one? 13, very good. Times the square root of negative 1, which is what? I. 3 times 13 times I. So then if you know 3 times 13 is 39, it's 39i. Does that make sense to you? Okay, so this is just basically dealing with square roots that happen to be negative. And you got to know a few common ones. Square root of 72, nobody knows that one. But they can break it up into negative square root of 9 and the square root of 8. Would you please finish that one and write it correctly? I know some of you are going to think, like, where do I put the I? Does this one have an I? No, because the negative isn't on the inside. Just because there's a negative doesn't mean it's imaginary. If there's a negative under the root, that's when there's imaginaries. So final answer, negative 3 root 8. No, it's not. Can't do that, because the square root of 8 could be simplified more. I bet I got some of you. It is negative. It is 3. But this needs to be broken up into root 4 and root 2. And that part's really 2, which multiplies by the 3. So it's negative 6 root 2. Who had that before I said it? Nice catch. All right. So this is all under the umbrella of problems that have I in it, which really is about imaginaries and complex numbers. This is so important that I put it on my top 20. In case you're like struggling with what the heck makes 63, is there a 9 in there? Yeah. 9 times what? 9 times 5 is 45. 9 times 7. All right. So use that and simplify this down. Now, I saw a frightening number of kids who got a 3 here and then canceled these 3s. You cannot do that. Why not? Because this part can be factored, and if you can factor it, you should. Are you just staring at the board over here? No, staring at the problem. At least you're on the right problem. Now, if you actually do it, the square root of 63 breaks up into 2 parts. If you missed it, it's 9 times 7. Why are you breaking up the negative 1 under its own separate root? Because that's how you can see that it's actually I. This part's 3. This part's I. So it's 6 minus 3i root 7 all over 3. No, you can't cancel those 3's right there. Why not? Because this is to be factored out first. Then when it's out here, then it'll be able to cancel. Okay. Mr. Cox, what does factor out of both of these?
3.
And then it's here now. And what's left?
2 minus I.
Very good. That's it. And then these cancel, and there's your answer. 2 minus I root 7. Okay, so that one is tricky. It's got quite a few little steps, but it's on my top 20 most important things. Unfortunately, given that the median score in here is barely passing the top 20, we got some work to do on algebra, but we'll get that fixed in second semester if you still have issues with things like this and other important algebra. All right, what if you just have a whole bunch of i's, like I to the 6th or I to the 16th? Well, I'd break it up into a whole bunch of I squareds, and I'd write it this way: I squared times I squared times I squared until I got enough. And is that enough? Yeah. So what is I squared? Why did I use y squared? Because I squared equals, do you remember? -1. And that's important. Because then this is just -1 times -1 times -1. And what's that? -1. Final answer is -1. So again, if you were given ones that have like this, for example, you'd want to break this up into a bunch of I squareds until you run out, and then you're like, but I guess I have to put one more I. And that's okay. So then that'll be -1, that'll be -1, and they cancel because -1 times -1 makes 1. And then it's I plus I. What's that? 2I. All right, so there's how to deal with I to a power. All right, next kind of problem that you have to remember how to solve. This, you could multiply it all the way out, set it equal to 0, which kind of already is, and then eventually use the quadratic formula. But that's got a lot of steps. And then the quadratic formula itself has 16 parts. I can prove it to you because you have to memorize it, so I'm going to remind you. X equals, that's 2 parts. Negative, if I forgot that, it wouldn't be right? It has 3 parts. 4 parts. 5, 6, 7 parts. 8, 9. If you forget any of those little pieces, it's wrong. 10, 11, 12, 13, 14, 15, 16. And if you start counting the time signs in there, it's even more. That's 16 parts to remember the quadratic formula. And it's on your test, so hopefully you know it. When would you ever use a quadratic formula? If you've got a quadratic and it won't factor. That's the only way to solve it then. Well, that's not the only way. You could actually graph it, but that takes a long time and it's really tedious. All right, so why are you bringing it up if you say not to use it? Well, because sometimes you should use it, but on this one, everybody subtract 1 from both sides. And I'll show you a much faster way than using a 16-part formula. Subtract 1 from both sides. This is problem B under number 2. To be or not to be? That is the question. Okay, and then I've got -1 is equal to x plus 2 quantity squared. Then I'm going to square root both sides. That's a faster way than breaking out the quadratic formula, in my opinion. I equals, would you have remembered the absolute value bars? Who had it before I said it? Nice. A lot of people forget that. When you square root a variable, you have to bring in absolute values. Okay, so then how do you solve it from here? Well, you have 2 equations. One of them is exactly what you see except without the absolute values. So I equals x plus 2. And then you subtract 2 and you get I minus 2. Or -2 plus I. It's even better. And then the other equation is exactly the same as the first equation. And you can make either side be negative. But when there's only one thing on a side, it's so much easier. I just put the negative here. I could put the negative on the other side, but it would have to be distributed to both the x and the 2. Either way it would work. All right. So fast. So many things to learn. All right. This D here. Oh, I really feel like I should factor it. Well, that would be the way to go. And it proves once again that if you can factor it, you should. Why is that handy? Because now I know the answers, like, it's so easy when it's split up this way. I got two answers, 3 and -3. Do you get that tons of people would have said the answer was just 3? Because they'd be like, I could stick a 3 in there and it equals 0. And they'd forget the other answer. But if you factor it, you'll be forced to face that there's 2 ways to get it to equal 0. This way with a 3 and this way with a -3. So again, I say to you, if you can factor it, you should. Okay. On to this page. Everybody get to this page. Now, there's 2 ways you can do this from here. You can use x equals -b over 2a. Most forgotten little formula in this class. And you can also do complete the square.
Is that in a different document?
Complete the square?
No, that page. It's not in.
Quadratics B.
Yes, no.
Is it? Have we moved to a new document?
Yeah.
Oh, okay. Sorry about that. I should note that. Yes, we have. Okay, everybody find this one now. It's called Quadratics B. I'll give you a second to find this one so you can take some notes on it. The good part is we're in the last chapter that we have to cover for today. We've moved from that complex stuff to the quadratics stuff. And if you feel like we already did quadratics, you're right. This is the more complicated quadratics that have like real world problems with like a ball in the air and stuff. So I'll remind you all about that. Quadratics B, are you ready? All right. So first, I'm faced with this and I'm thinking if I can factor it, I should. And I should probably factor it. But I really should like try to figure out what do they want. Will factoring get me vertex form? No. Will factoring get me the zeros? Yes. So I may as well factor it. Once again, if you can factor it, you should. Comes through. Everybody get that factored. Chase, help me factor it.
X minus 6, x minus 2.
Minus 6 minus 2. Double checking you. That's negative 6x. That's negative 2x. That makes negative 8x. Nice job. And so now I know the zeros. X equals this and x equals that. The two things that could make it equal 0 are 6 and 2. And I know some of you are like, don't you have to put them in parentheses? You can if you want. They're x-intercepts, so their y is 0. And you could say 6, 0 and 2, 0. I'd accept either of these ways of writing the answer. Now, how about the vertex, though? That's not giving me the vertex. The vertex, you really ought to use the most commonly forgotten little formula. Does anybody in here remember it?
Negative d over 2a.
Except the beginning of it.
Oh.
What equals that? You're not wrong, but x equals negative b over 2a. It totally matters that that's an x because it's the x of the vertex and it's the axis of symmetry formula. A ton of people would not have remembered that. This studied right before your test would be really smart because like the final's not for like a week from now. And all of a sudden you have to do this, like find the vertex thing and you're like, I can't remember what the formula is. If you'd looked at it just a few minutes before, oh yeah, this is how you get the vertex. All right, so negative b is negative of negative 8, which is 8, over 2a, which is 2, which means x is 4. Is that the whole vertex? No, it's the x of the vertex. So it's 4 comma something. And then to figure out the other part, you just stick the 4 in the function. I'm going to put it right there. And that's going to come out to 16 minus 8 times 4 is 32 plus 12. Well, that's going to make negative 16 plus 12, which will be negative 4. 4 comma negative 4. Is that what you guys got?
Yeah.
Cool. Then that's the vertex. Boy, what's vertex form? It goes like this. Y equals parentheses x and then that squared. And this is where you put your vertex. I'm going to on purpose make a really common mistake.
What we do minus 4 because it's in the parentheses.
Yes, the thing on the inside you don't trust. That should be a minus 4. Okay, then, did anybody even think about whether there should be like a 2 in the front. If you didn't even think about that, you snooze, you lose. There was no stretch factor here, but did you even think to look for one? It's really easy to make. If there was a stretch factor in the front, you'd know it because it would have been in the front of the original equation. But if you didn't even look for it, you might have forgot that there is an A of 1 there in this case. If there had been a number in front, we would have just copied it right there. Okay, now another thing I should teach you is how to do what's called complete the square. Here's the vertex. The domain's pretty easy. It's just what you can safely feed the function. And in this case, there's no square roots or anything, so the domain is just all reals. You can let it, this function can eat anything. The domain is also, if you draw this thing, you'll go, oh, it's a parabola with a vertex down there. What's the domain of a parabola? It's all real numbers. All right, the range is probably handy to have that sketched, because if I draw this with a sketch and then I ask you the range, it's like, oh, it's easy. The range goes from -4 to infinity. But just looking at the equation is not easy. So whenever I do a range, I make a sketch like that. Okay, I also want to remind you on number 3 how you could do complete the square. Does anybody in here think they could do number 3 with complete the square? You will have mad respect from me if you can pull it off. But as soon as you make a mistake, I'm taking over. Do it.
All right. So
Everybody follow along, and I'll tell you if he's wrong.
just to clarify first, this is the one where you put space in it.
Yep.
Yeah, okay. To 2x.
I'm just rewriting the problem right now.
2x squared plus 12x, and then you leave a space.
Yep, good so far.
Plus 14 over.
Now, I'm going to put a parenthesis around this because we want that part to factor eventually. Do you guys remember this deal where you do half and squared? You're a good so far.
Yeah, so you take half of that 12.
Oh, so close.
Oh, because the 2 you have to factor out the 2.
Yes. Okay, so now he caught his own mistake. The 2 gets factored out first. And I know it feels like that we should include the 14, but we do not. The 14 got set aside, and it's still set aside. It's way over there.
Plus 6x, so you take half of that 6, so that's 3, and then you square it to 9.
Correct, that's positive 9 there.
And then there's a 2 in front, so instead of just doing negative 14, or by doing minus 9, you have to times that by 2 first.
So he remembered this deal, which I knew a lot of people would forget, but you caught it. That 2 is scaling up the 9 by 2, so you have to times this one by 2 also. So then, can you pull off the final answer?
And then in parentheses, x squared plus 6x plus 5.
Just factor that.
Oh.
Oh.
Oh, I didn't factor it. No, you're right.
If you can't, don't factor. I mean, who do you even think you're talking to? You've got to factor it. So, see if you can do it.
Yeah, so,
Hey, nobody else had the guts in here to even try, so I'm impressed that you're this far. Somebody want to help him out with what it factors to?
It's x plus 3.
Plus 3.
yeah, x plus 3 and x plus 3.
Okay. And yes, x plus 3 and x plus 3, but then you might as well put them together and say squared. And then there's a negative 18. I'm going to finish it off.
So then it's minus 4.
Yep. There it is. Nice job. That was a hard one. You stepped up to do probably the hardest we could ever do on a final like this. I mean, you could make them harder, but they'd have decimals and they'd be like impossible. This is doable. Did he catch what he did there? He realized that these both had a 2 in them, so he factored it out. Then he did the half of the 6 is 3, and he squared it, half n squared. Then he remembered that this 2 had to get multiplied by the 9, so you have to also multiply it by the negative 9, because these are supposed to cancel each other out. All right. Now, I know you may not recall that one. You might get that one wrong on the test because this is a really hard process. But what's it good for? It just got me vertex form. And I know the vertex because I can see it sitting right there. It's -3 comma -4. And then once I have the vertex, it's really easy to sketch it and go, okay, well, if the vertex is at -3, -4, then the vertex is like down there and it's a right side up parabola. So I know what the range is because I know how low it goes. And it goes to -4, so then that means the range must be from -4 to infinity. And the only thing it doesn't really tell me is x-intercepts. Since you were the man of the hour on that one, JP, can you finish it? Well, how would I do the x-intercepts?
You have to set x equal to 0.
Okay, so what you just told me is how to find the y-intercept.
Sorry, you have to find what makes y equal 0. Sorry.
Okay, you are correct.
That would be -3 if you put it into the
Nope. And once again, the thing you're forgetting is my favorite thing.
factoring.
Yes, you got to factor it. So, can I factor out the 2? Yes. This time, for this kind of factoring, I'm factoring the 2 out of everything. And I get x squared plus 6x plus 7. And then, does it even factor? Let me think. 7 and 1. I don't think this one factors any more than that. So then we can't get nice, easy x-intercepts. Remember the saying, if you can factor it, you should? But what if you can't factor? Quadratic formula. Ugh. Wow, this is an intense chapter. Some people only covered this one chapter today because it's that intense, and I get it. I'm trying to cover enough so that I can teach you live and in person through the end of this week and cover pretty much everything. And then my review video that I'll have on Monday will be like a review of the review. All right, so anyway, I know this is super intense. Why can't I get it factored all the way? It just doesn't factor. So if it doesn't factor, you got to use the quadratic formula, and I don't even want to do it. It's going to take that long. So that begs the question, do you have to do it? Well, no. The only thing I'm assigning today is one Schoology quiz. You'll see if you look in your upcoming that there's one Schoology quiz assigned in there. All right, I'm not quite done with today, but just so you know, you don't have to do the paper versions of these worksheets. Would it be good for you? Sure. But I know you only have so much time in your life. And what I decided is I'm not going to just give you a complete autonomy to not do anything this week because some of you would make bad choices. So I am giving you a small little assignment of the Schoology quiz today. And you can do that in a minute. Everybody get to this page, because I got to remind you what the heck the discriminant is. Again, another little equation. It's not as commonly forgotten. Just wait. I want to see how many of you think you have the discriminant in your head. Just be honest. I won't like be mad at you if you're wrong. How many of you think you know the discriminant? All right, that's like 7 of you. Okay, cool. Now who's willing to actually volunteer it? You first. Take.
Is it the inside of the?
It is. So the discriminant is. Yeah, but what is it? Yeah? That is correct, sir. That is the discriminant. B squared minus 4ac. Notice we don't square root it. Now, do you think that'd be another handy thing to look at right before you took the test? Only 6 kids in here remember what the discriminant was. That means even though we just reviewed it, probably be smart to have this one written down so that you can quick scan through all of these notes I've given you right before you take the final, so that you're like, oh yeah. And this is the one where if the discriminant, the thing under the root, is negative, then there's no solutions. You know, remember the number of x-intercepts? There won't be any if the discriminant is negative. What if the discriminant is positive? Then there will be how many solutions? 2 solutions. And then there's something in between, which is there's one solution.
And it's the vertex.
And it's the vertex, yup. And it'll be when what?
0.
Discriminant equals 0. Good. So if we actually do this discriminant here, we would do b squared minus 4ac, and b is negative 12. So then squared, it's going to be 144 minus 4 times a, which is negative 3, times c, which is negative 9. Those numbers are pretty big, but I'm pretty sure, if I memory serves, I'm pretty sure this comes out to 36. Can anybody? Yep. Some kids are verified they got 36 also. If this equals 36, how many answers will there be then? 2, because it's positive. If that's positive, you get 2 answers. I know this is really brutal, but you'd have a calculator, you'd just type it all in, and it would say 36. And as long as it comes out positive, you get 2 answers.
If you factored the equation first, would you get the same answer?
Yes, you would. That's a good question. You just have to make sure that you factored in that you factored it. So, all right. So, what else do we have to know? Well, this one, you could play with it for a while, but you'd figure out it doesn't factor. So, like Mr. Server's favorite thing. Do you remember yet? I said it already once this hour. If you can factor it, you should. But if you can't factor it, quadratic formula. So you'd have to use a quadratic formula here to get the solutions. Could you find the vertex by completing the square? Yes, you could. I'm just going to show you real quick on an easy one how easy complete the square can be. All I did is move it to make room. And I jump right into half and square. And half of 2 is 1, and 1 squared is 1. So then I go plus 1. That part factors. Cool. It always will. And then if I do plus 1, I got to do minus 1 here. And then this simplifies down to x plus 1 and x plus 1, so x plus 1 squared. And that's negative 16. See how quick that was? And I've got the vertex. And I've got it in vertex form. Yes?
Can't that factor x plus 5 and x
Oh my
minus
gosh,
3?
maybe you can. What does it factor to?
X plus 5, x minus 3.
Hold on. X plus 5, x minus 3. Double checking you. That makes negative 15. You are correct. Nice job. That doesn't mean that that what I just did was wrong. This still worked. But when I was wrong was when I said you'd have to use the quadratic formula. Just so you know, if you had used the quadratic formula, it wouldn't have hurt you. You still would have got the answers, but it is way slower. Thank you for catching that. Negative 5 and 3 are the x-intercepts, because that one did factor. Oops. I'm glad I'm remaking the video from last hour, because I goofed that one. I also said that one wouldn't factor last hour, but turns out it does. Okay, what's different about this one? What do you got to start with then? This stumps a lot of kids, and it's really not that hard. Every quadratic we've ever had has always been set to 0. Is this set to 0? No. So you just got to set it equal to 0. So I agree. Subtract 2x squared from both sides, and you would be on your way to setting it equal to 0. Good enough on that one. And when they say simplified radical form, that usually means that your answer is going to look like this. You know what I mean? It's the end of a quadratic formula problem. So another reason that I kind of thought that it wasn't going to factor is because usually when you use the quadratic formula, you get a simplified radical form kind of answer. Sometimes they just simplify all the way down to like 6 and 12. Cool. They don't have to have square roots in. All right. Almost done, ladies and gentlemen. On these, you just want to set them equal to 0. That's the only trick for 10 and 11. They just got to be set equal to 0 first, and then if you can factor it, you should. If you have to, you use a quadratic formula. Does it say decimal form? If you ever have an answer that's like this, you get the decimal for the 7, and then you just go 3 plus that decimal divided by 8, and 3 minus the square root of 7 decimal, whatever it is, divided by 8. So decimal form, you would replace this part here with whatever the decimal is for the square root of 7. Okay. How many solutions does this one have? 2. So then the discriminant must be good. How many solutions does this one have? No solutions. So the discriminant must be negative. And this one's got how many solutions? So and it's the vertex, see? And that must mean the discriminant was All right, good. And the last general category of problem is real world quadratics. Please draw this with me. It's what every single one of these can be boiled down to. You got this little arc because you're throwing a ball. And that ball goes up in the air and it goes all the way to the top. And then that's the vertex. And then it comes back down again and hits the ground. And that's the x-intercept, aka the solution, the root, the zero. So do you know what formulas to use for what? I will remind you right now. That's the vertex, right? And to do that, you'd want to do negative b over 2a for the x of it. And you'd want to stick in whatever that came out to be into the f. So I say f of negative b over 2a. That reminds you to stick whatever that is into the formula. What formula are you talking about? They usually give it to you. In a moment, I'll remind you how to write one of those formulas. Let's just zoom in on it for just a second. Always, for our units, we're on planet Earth and in meters. So it'll be always negative 4.9 because it has to do with gravity and gravitational constant. This is the, anybody remember? Velocity. And that part there, height. Yes, the start height. So many little things to remember, but with this help and you paying attention, which most of you are, and taking good notes like most of you are, it's going to really help, especially if you take one last look at this right before the final. All right, so that spot right there, that's the vertex. That spot right there, that's the ball hitting the ground, but it's not where the ball hits the ground. It's when the ball hit the ground. Very good. So this is when the ball hit the ground. And what tells you that? Well, you got to go back to like a different mode of thinking. Like that looks like an x-intercept. How do I find those x-intercepts again? Well, usually you factor, but in the real world with a negative 4.9, you're not going to be factoring it. So if you can factor it, you should, but you won't be able to factor it. So what do? Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that was really messy, but I sang it to you, so deal with it. Hopefully you know how to write it. Okay, so last thing on this picture is that spot. That's where
It
started height. Start height.
And that's the y-intercept.
AKA the y-intercept. Very good. And this is always time. And this is always height. All right, so there's the big picture. Now, one more thing they could, or two more things they could do. They could say, I'm going to give you the time. Time is 3 seconds. Well, there's only one place you could put it. If they give you time is 3, you've got to put it here. That's the only logical place to put that time is 3 thing. But what if they don't give you the time? What if they give you the height? Like they say, I want the ball to go 13 feet high, or meters high. Well, there's only one place you can put a height, under h of t. So if they say the height was 13 meters high, you'd put the 13 right there. That's where height goes. And this is where time goes. So if they give you the time, you can figure out the height. If they give you the height, you can figure out the time. And I know a lot of you would be like hard-pressed to solve that. Like, how the heck do I solve that? You set it equal to 0, and then how do you solve it? Well, if you can factor it, you should, but you can't. So then you got a quadratic formula. So you'd take this, subtract 13 to get it equal to 0, and then you'd use your quadratic formula to solve it. I know that was incredibly intense, but that was a month worth of math, ladies and gentlemen. There's like, this is just the same thing from as the last problem. It's just they don't give you the equation, but I told you that part. It always starts with y equals negative 4.9 t squared, and then you always put the velocity, which they tell you, right there. And then you always put the starting height, which they tell you, right there. So then you've got your formula and you're off and running. I would always draw a little picture to try to remind myself, what are they asking me about? Oh, 30 meters off the ground. They just gave me a height, must be like that. Oh, wait, the ball's gonna go past it twice. 30 meters, I'd have to put it here. When will the ball hit the ground? Ooh, that's this one, quadratic formula. And what's the height if the ball's on the ground? Well, it's 0. So it makes sense that you'd put a 0 here. If the ball was height of 0, it means it's on the ground. And then you could use a quadratic formula. Use a quadratic formula a lot in this one, obviously. All right. And this page is, all it is a review. I think it got like the order got jumbled, and this is actually from the complex numbers stuff, and I don't understand why. But if I had to just give you one piece on this page, and I know it's in a different area, but just watch with me for a second. Could I solve this by multiplying it all the way out? Yeah, but it would take forever. So I would do square root and square root. And then right away that gets rid of your squared, and you have 2x minus 4 equals 8i. And thank you. I was going to say I on purpose just made a mistake. I was going to see who remembered that there's absolute values when you square root both sides. And I know some of you would rather multiply it all out and use a quadratic formula. You can. It's just slow because the quadratic formula has 16 parts. So if you do it the way I just suggested, now you'd have to break it up into 2 equations. 2x minus 4 is 8i, and 2x minus 4 is negative 8i. I totally get this is a lot, and maybe for some of you it's just too much and you couldn't pay attention all hour. I did record it on a video. You'd be able to go back and rewatch it, and that would probably be smart if you were zoning today, because this is like a really intense day with a lot of final questions on it. Tomorrow we will do another double unit review, and if you're taking good notes, that's going to help, because you're going to go through and look at these right before you take the test, and you'll be like, when I hit this kind of question, oh yeah, I guess I should break it up into 2 parts and do, instead of doing the quadratic formula, I'll do it that way. Just these little reminders right before the test would be really smart. So I'm hoping you're taking notes. All right. This one was the one where if you ever have an I squared, you replace it with -1. So like this would be 3i squared plus 4i. And you go, oh wait, that's -1. So then it's -3 plus 4i. Okay, cool. We've made it. And that's all I got for today.